Good day everyone! Today we'll explore the elimination method for solving simultaneous equations. So this method is useful for finding the point of an intersection between two linear equations that you have to solve by finding the pair of x and y values that have solutions to both of them. So an x value and a y value that would work for both of these equations. Now, this method is kind of complicated when you first learn it because it can involve a lot of steps. So in this video, what we're gonna do is to go through this example here first, which is relatively easy one and will hopefully get the idea across. The basic idea of elimination method is that we're going to try and combine these two equations into just one equation. But importantly, when we do that, we're going to try to eliminate either the x's or the y's at the same time so that we only have one unknown variable left in our equation. For example, because both of these equations have two y's, if we subtracted this whole second equation from the first one, then we'd eliminate the y's because 2y minus 2y equals 0. And then we'd only have the x terms and the numbers left, so we'd be able to solve it. First thing we want to do is label our equations 1 and 2 so that we know which is which. And then the new equation we're forming is going to be equation 1 minus equation 2 or equation 3. So we do 7x minus 3x to get 4x, 2y minus 2y, which is 0. Remember, we wanted to cancel out otherwise. And 23 minus 11, which is 12. So we end up with 4x equals 12, which we can then solve by dividing both sides by 4 to get x equals 3. Now that we have found the x value, all we have to do is substitute that back into one of the original equations to find the corresponding y value. It's up to you which one you pick, so just use whichever one you think looks easiest. So I'm going with this first one. So when I substitute 3 to x, that will give us 7 times 3 plus 2y equals 23. 7 times 3 is equal to 21 plus 2y equals 23. Then we'll have to isolate the variable and the constant. So you have to subtract 21 to both the sides of the equation to get 2y equals 2. And finally, divide 2 to both sides of the equation, so that will give you y equals 1. So our solutions for this equation are x equals 3 and y equals 1, which means that these two equations, when graphed, will intersect at point 3, 1. So if we just quickly think back to what we did for a second, remember that first of all, we combined the equations to eliminate the y terms. And then we use the combined equation to find the value of x. And then finally, we use the value of x and one of the original equations to find the value of y. If you want to double check where the answer is right, which is generally a good idea in the exam, you can try substituting both sides of your values into one of the original equations to check if it works. But because we plugged the value of x into the first equation a minute ago, when we try to find our y, you should use the other equation this time. So, in this case, we should use the second equation. 3x plus 2y is equal to 11. So, we're going to substitute 3 to x and 1 to y. So that will be 3 times 3 plus 2 times 1 is equal to 11. So 3 times 3 is 9 and 2 times 1 is 2. So if you're going to add that, that's 11 equals 11. So our solutions are correct. Now, can you try to solve these simultaneous equations using the elimination method? So we have 4x plus y is equal to 10 and 3y is equal to 2x minus 19. So remember, you have to rearrange the equation so that they will look the same. Just follow these steps. So step 1, you have to label the equations and rearrange to correct form. Step 2, get the same number of x's or y's. Step 3, eliminate the x's or the y's. And then step 4, solve equation for x or y. And then substitute in the value you found to find the other one. And the last step would be you have to check your answer. So good luck!